Hello, everyone, and welcome back to another Planetarium show. My name is Jessica. I am the director of the Planetarium. Being our voice in the sky tonight is Eli, who had to step away for just a second, but will be joining us once he's finished. So, our show tonight is going to be taking you on a tour of the moons of the solar system. There are a lot of them in our solar system, and many of them I would say are as interesting, if not even more interesting, than some of the planets in our solar system. So as I get everything switched over and set up for the show, as always, if you have any questions for us tonight, feel free to leave them down in the comments. Eli, once he gets back, is going to keep an eye on those for me and will let me know as they come up. We'll also have time at the end for questions as well. And with that, we will get started. So, for our tour of the solar systems, or of the moons of the solar system tonight, we are using this program. Basically, what we're just seeing is the result of 4.5 billion years of being hit over and over and over again by space junk. But if we look at these darker areas, we see some differences, not just in the color, but we also don't see as many craters in these areas. So these darker areas are known as lunar maria, which is Latin for sea, a body of water. And that all comes from a time before we had telescopes. When people looked up at the moon and they saw these dark areas, they thought, hey, that looks like a body of water. That must be what it is. We since know that's not the case. It is rock. There is no water on the moon, or at least not a lot of it in like a big body of water like a sea. And so we know it's not the case, but the name stuck, and so we still call it that. But that darker color comes from the fact that it is a darker mineral rock than the highlands. It's actually a basalt, a lava rock. And that tells us that these darker maria are actually ancient lava flows. So about 3 billion years ago, when the moon was still warm enough to have molten rock under the surface, it got hit by some really big things which cracked open the crust and allowed that molten material to well up to the surface and then flood the surface, filling in the craters that had already formed. Just like, paving over potholes in the road. And so it smoothed out those areas, which is why we don't see as many craters there. And of course, it's cooled and hardened and solidified, and now we just have these patches of dark basalt all over the surface of the moon. So yeah, that is a little bit our moon. Trying to get it centered again. There we go. All right.
We got a question a little while ago. Do any of the moons have a moon, or is that even possible?
It is possible. I'm trying to think. I don't know of any, but is possible. I mean,
It's usually that if the moon were to have its own moon, usually the planet would take that over anyway.
yeah, usually the gravity from the planet would kind of pull it away. So yeah, it's not that it's impossible. It's just wouldn't be around for a long time.
They're called sub-satellites, though.
Yeah, that's cool to have it. So it must happen enough for it to get its own name.
Well, I think we probably make the vast majority of them.
Oh yeah, that's true. That would make sense. Okay, so we are going to head on to our next planet here. So our next planet is Mars, and Mars has a couple of its own moons, two called Phobos and Deimos. And let's go take a look at Phobos. So this is a little bit different than our moon. At the planetarium, we lovingly call these lumpy space potatoes because, I don't know, you guys tell me. It looks like a lumpy space potato. Definitely looks different from our moon. Much, 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 much smaller. Not nice spherical shaped, although it is covered in craters like our moon is. But because of its size and shape and what it's made of, it's made of rocks. We actually believe Phobos and Deimos, Mars's other moon, are both captured asteroids, which isn't that hard to believe. I mean, Mars is right beside the asteroid belt. So it makes perfect sense that a couple of asteroids just got a little bit too close to Mars, and Mars's gravity was able to grab onto them, and they became moons of Mars instead of orbiting the sun. Now, Phobos is in a bit of trouble. Phobos orbits so close to Mars that Mars is actually gradually pulling it in closer. And so it is slowly spiraling in closer and closer to Mars. And in the next, I believe it's 5 million years, it's one of two things is going to happen. Either that gravitational pull from Mars is going to get too strong and the moon is going to get ripped apart into lots of tiny pieces, and Mars will have its own little ring for a little while. Or if the structural integrity of Phobos is strong enough to withstand that, it'll just spiral in and hit Mars. They'll end up just colliding. So I believe it's about 5 million years. One of those two things is going to happen, and Phobos will no longer be with us. All right, well, heading on now to Jupiter, which has quite a lot of moons, which you can see as we are making our way in here. Jupiter has 80 moons. It was 79 for a while, but I believe just the other week it was announced that an 80th moon was found around Jupiter. Now, most of these are like Phobos and Deimos. They're lumpy space potatoes, asteroids that got just a little bit too close, and Jupiter's gravity grabbed onto them. Since Jupiter is a much larger planet than Mars, much larger planet than Mars, it's easier for it to grab hold of asteroids to become moons, which is why it has so many of them. But a few of them aren't lumpy space potatoes. The 4 largest moons around Jupiter are known as the Galilean Moons, because the astronomer Galileo is the first one to have discovered them. In fact, the discovery of these moons of Jupiter was one of the big pieces of evidence that Galileo used to show that the Earth and all of the planets orbited around the sun rather than everything orbiting around the Earth. But these 4 moons are very interesting in their own right. So we're going to start with the closest of the 4, and that is Io. Oops, forgot to click over. There we go. So this is Io. We have our own nickname for this moon. It's the pizza moon, which makes sense, right? You see that kind of yellow and white cheese, red sauce. Eli, we're not going to have the argument, so the black, whatever other topping you want it to be. But that yellow and red and stuff that you're seeing is actually sulfur. So I guess this would be more of a rotten egg pizza. More importantly, all of those black spots that you see here are volcanoes. Io actually has over 150 active volcanoes, which is way more than we have here on Earth, and actually makes Io the most volcanically active object in our solar system, which is a little strange because Io is actually a bit smaller than our moon. And yes, our moon had lava flows like 3 billion years ago, but since then it's cooled off and doesn't have that anymore. So how is Io still generating so much energy to produce all of this volcanic activity? And it turns out the reason for all of this is because of, oops, where are you at, Jupiter? There you are. It's because of Jupiter and the other moons. So we have Jupiter on one side of Io that's pulling Io towards it. And then we have the other moons on the other side of Io pulling Io in that direction. So Io is getting tugged back and forth. And as it's getting tugged back and forth, it's getting stretched and pressed and stretched and released. And that's causing the rocks to rub against each other. And just like you rub your hands together to warm them up on a cool day, as those rocks rub together, they generate heat and energy, and that has to escape somehow, and on Io, it escapes as a volcanic eruption. And so because of this massive tug of war that Io is stuck in between, that is what's creating all of that volcanic activity that we find on the moon. So yeah, kind of crazy. But let's head on to the next Galilean moon. So since Io was kind of the land of volcanoes, our next moon, Europa. Yeah.
Your video is frozen, it looks like.
Oh, yes, it is.
Also, in the meantime, we got 2 questions.
Okay, let's do questions while I try and fix my camera.
The first is, what happens to an asteroid when it crashes into a gas planet?
Good question.
Pretty much the same thing.
So why is my camera disappeared now?
You're gone now.
Yeah, I know. I'm trying to figure it out. Hold on.
They burn up from friction in the atmosphere. It's happened to Jupiter a couple times. We've seen it happen, and it causes like big explosions that are super powerful, like millions of nuclear bombs.
Yeah. So even though there's no ground, there's still an intense amount of friction and pressure and heat, and so they still get destroyed as they make their way plunge through the planet.
Yeah, I'll see if I can find pictures of Schumacher-Levy.
Yeah.
And then the other question was, do any moons rotate on their own axis?
All of them do.
Yeah.
Yeah, all of the moons rotate. Mm-hmm.
That's why we see only one face of our moon, is because it rotates.
Yeah. So they'll rotate in different directions and different speeds depending on different conditions, and I don't want to get too technical into it, but they do all rotate. Yeah. And that's just comes down to the fact that everything in the universe is kind of moving slightly. And so when you take material and collect it together, it keeps that movement, that rotation. So the material and debris that collected to form the moons or asteroids or planets or whatever, the resulting product has that motion left from the things that it was made of. And so that's why all stars rotate, planets rotate, moons rotate, asteroids, all of those things do. I will say, I guess it might be confusing, like they're not rotating on the screen right now because I have time paused, just so things don't get too crazy moving all over the place, but yeah, they do. All right, should we talk about Europa?
Yeah.
Yeah? Okay, we'll show the picture afterwards.
Oh, I was just going to put it in the comments.
Oh, yeah, that works. All right, so our second Galilean moon, Europa, is the land of ice. So it doesn't look super exciting at the start. We see just a surface covered in ice. There's some cracks in that ice, though, which tell us that Europa is going through a similar tug of war that Io is, but not as dramatic. Because Europa is further away from Jupiter, that tug back and forth it feels isn't as strong. But it is generating enough heat that we think underneath this icy crust is an ocean of liquid water, and quite a big one if our calculations are correct. There is likely twice as much water in Europa's ocean than we have on the entire Earth combined. That is a huge ocean, and that has astronomers incredibly excited, because one thing we know about all forms of life that we have found here on Earth is it requires liquid water. So when we see somewhere that has an abundance of liquid water, that makes us think, hey, maybe life could live there. Maybe life could have formed there. And so there are actually future missions that NASA and the ESA and other space agencies are working on to send a spacecraft to Europa, melt or drill through that ice, and explore that ocean below. Now, there's still a lot of work to do before this can happen. In fact, the first few missions that they're planning are more of reconnaissance, just to get more information before we plan for that lander. But they're working on it, which is very exciting, and I really hope that it happens in my lifetime, because I would love to know that there are alien fish in Europa's ocean, because that would just make me so happy. So the other 4 Galilean moons aren't as interesting as Io or Europa. I will still show you them both. Next up is Ganymede, which on its own is actually still a pretty spectacular moon when you realize how big it is. Ganymede is actually the largest moon in our solar system. It is bigger than the planet Mercury and about 3/4 the size of the planet Mars. It is a giant moon. And just like Europa, it is covered in ice, may have a small ocean of liquid water under its surface, but we are not quite sure about that. And then the last of the Galilean moons, the furthest from Jupiter, is little Callisto, which doesn't look like much. We have really just a icy, dirty surface with lots and lots and lots of craters. It's far enough away from Jupiter that it doesn't experience any of that kind of tugging that Io and Europa go through, so it doesn't have any really interesting features or effects, because it's kind of left alone out here. All right, so let's make our way to our next planet.
We got another comment. Can all 4 of Jupiter's largest moons simultaneously transit as seen from Earth?
Yeah, I don't see why not.
Yeah,
Yeah. I can't think of any reason that they couldn't.
Doesn't Ganymede like not obey some orbit thing though?
Not that I know of.
Oh, maybe I'm just making that up.
Yeah. I mean, it's more of just getting that timing to all line up.
Yeah.
So yeah, it can happen. You just have to catch it at the right time. All right, so Saturn also has quite a lot of moons. Actually, more than Jupiter. It has 82. Most of these, like Jupiter's, though, are lumpy space potatoes, although they are kind of a mix of asteroids and comets that got caught by the planet's gravity. So we have a lot of icy moons around Saturn, which also makes sense because we're even further out from the sun. It's even colder out here, so we're starting to find lots and lots of icy stuff. But Saturn does have quite a few interesting moons as well. The largest of Saturn's moons is a moon named Titan. It is the second largest moon in the solar system, right after Ganymede. And so it is also larger than the planet Mercury and smaller than Mars. But what also makes Titan very unique among the moons in our solar system, which you can see here, is it has an atmosphere. It actually has a pretty thick atmosphere, about 1.5 times denser than Earth's atmosphere. And we don't see that on any other moon. They don't have atmospheres at all, let alone a thick one like Titan has. And this is kind of a unique combination. This happened because of a perfect set of circumstances. We're far enough away from the sun that it's so cold that the gases move very slowly, slow enough for Titan's gravity to be able to hold on to them, so they, instead of drifting off into space, they stay with the moon, and you have this thick atmosphere. And so we really didn't know what was going on underneath these clouds because they're so thick we can't see through them until the Cassini spacecraft got to Saturn. It used radar to peer through the clouds, but it also released the Huygens probe. Yes, yes, Quinn, that's right. It released the Huygens probe that fell through the clouds, took measurements, took pictures, landed on the surface of Titan, and showed us, hold on, click on it. Ha, there we go. Showed us what the surface looks like. And it's quite interesting. We see features that show erosion, showing us that there's got to be some form of liquid flowing across the surface. And in fact, Cassini did end up finding around the North Pole, you can see it right here, and I believe around the South Pole as well, that there are huge lakes. But these aren't lakes of liquid water, because it's far too cold for water to be a liquid out here. These are lakes of liquid methane. And while we don't know, we don't have a form of life here that lives off of liquid methane, that doesn't mean it's impossible. And so Titan is another one of the places that we are incredibly excited to try and explore and understand better, especially to look if there are other types of life that could develop that aren't at all like what we have here on Earth. And in fact, there is a new mission in the works called Dragonfly, which is a little quadcopter that is going to fly around Titan, because it can do that. It has an atmosphere, so you can fly through it. And Ingenuity on Mars has proved that we can fly things on other planets, on other worlds. So Dragonfly looks like it's going to be the second to do that. One other moon of Saturn I want to point out is Enceladus. So Enceladus is a lot like Jupiter's Europa. We have this icy crust, and underneath that is an ocean of liquid water. But a benefit to Enceladus, and I wish that we had a way to show it through this program, but down here near the, down here near the South Pole, there are these cracks in the ice where you actually see plumes, jets, vents of water coming out from the interior of the moon. And so it's actually a way for us to easily sample what that ocean might be like without having to drill through the ice and send a submarine down there. And so this is another potential place that life could have developed, and a way for us to kind of explore it a little bit easier than, say, on Europa, than on Europa, although that is still like our top priority, because one, it's closer and easier to get to, and two, its ocean is supposed to be much bigger than Enceladus's ocean. But yet another potential place for life in our solar system. All right, so let's head on to Uranus, which has, I believe, 27 moons. Unfortunately, none of them are that interesting. I wish there were some really cool ones that we could go see, but they're really all just chunks of rock and ice. The most interesting of them is, let me find it, there we go, Miranda. But it's interesting because of its unusual kind of markings, which has left scientists kind of trying to figure out exactly where some of these markings have come from. Unfortunately, we just don't have a lot of information on the moons of Uranus and Neptune, because we can't really study them from here on Earth. They're just too small and too far away. And we've only had one spacecraft fly by. That was Voyager 2 back in the 1980s. So we have some general ideas of number of moons and some basic properties, basic characteristics. But there's not a whole lot that we know right now about them. We really, really need to send some more missions out to Uranus and Neptune. They've just been sadly neglected. So that leads us to our last planet, Neptune, which has, I always forget if it's 14 or 17. I believe it's 17 moons. But it does have one that is quite interesting, and that is Triton. Now, Triton is a bit of an unusual moon because when we look at the other large moons around the other planets, they all orbit their planet in the same direction that the planet rotates. And that again comes back to that commonality of motion in the things that built up the moons and the planets and stuff. However, Triton does not. Triton actually orbits in the opposite direction as Neptune rotates. And that tells us that Triton must actually be a captured moon. It's something that formed elsewhere, and then Neptune's gravity grabbed onto it at some point in the past, and it became a moon of Neptune. This makes it the largest captured moon that exists in our solar system. But what's interesting is where it comes from. Triton most likely is from the Kuiper Belt, which is where Pluto and some of the other dwarf planets live. So if Triton was still out there, this would be considered one of the other dwarf planets, just given its size and stuff. But it's a way for us to study the objects in the Kuiper Belt without having to go all the way there. But again, we don't have a lot of information because only Voyager 2 has gone by and taken pictures and data of it. So just lots that we still need to learn about these outermost planets here. And that wraps up the moons of the solar system, at least the moons of the planets in the solar system. Dwarf planets, some of them have moons as well. Pluto has 5 moons. There are also asteroids that have moons. So this is Ida, and oops, forgot to click back over, sorry. Ida and Dactyl. Dactyl, where are you at? There he is, right there. So planets aren't the only things to have moons, but we are kind of at the end of our time, so I will stop there and see if we have any more questions.
We do have one. What are the average temperatures on the moons that do have water?
So for like Europa and Enceladus most.
Very cold on the surface.
Yes, very, very, very cold on the surface. You have water, liquid water underneath the surface because you still have some heat in the interior of the moon that's keeping it warmer. And obviously it has to be warm enough for water to be liquid, for it to be, an ocean. But I'm not sure what temperatures are like. I mean,
Europa's surface temperature never rises above negative 260 Fahrenheit.
There you go. Yeah.
So, and I think it's really interesting why that heat is generated at the core. It's because the gravitational interactions between the moons and Jupiter cause friction in that crust that's underneath, so it heats up, and that's what warms it.
Same thing that drives Io's volcanoes.
Yeah. Kind of interesting.
Yeah, and Enceladus is doing the same thing. Enceladus has a similar tug of war going on between Saturn and the other moons, and that's what keeps it warmer and allows that liquid water underneath the surface.
I wonder if, well, I mean, I guess this will be something we'll figure out when we go there, / if we go there, hopefully. I wonder if there's like vents or anything like that. Like I don't understand how that would work, but I wonder how that heat, if it's just purely from convection in the crust, or
I think, at least I know for Europa, they do think that there are like vents on the ocean floor.
Wow.
Because that's one of the reasons why it's such a strong candidate for life. Because I mean, early life on Earth developed underneath the ocean near volcanic vents.
Yeah.
So with
Hmm.
those similar conditions, it's extremely possible that life could develop there as well.
Wow, that's awesome.
Yeah,
Cool. Well, that's it
telling
for
you, I want
yeah,
alien fishies.
it'd be like Subnautica.
Yes. Okay, but like that little cuttlefish that you can have as a pet in
Yeah.
Subnautica
Yeah.
is
That's
adorable.
in the first one, right?
Yeah, the first one.
Yeah.
So I think it's like you get an egg and it hatches from it.
Yeah, it's like when you go to the like the shipwreck.
Spoilers for anyone who wants to play the game.
Yeah, it's a really good. Oh, there are five. You can have up to five of them.
There are.
Yeah,
They're so cute.
yeah, they are pretty.
All right. Um, so if anyone has any other questions, go ahead and leave them in the comments. We'll take a few more minutes to see if any more questions come through. And then I will also tell you about what's coming up over the next week. So on Wednesday, we have a show called How Do We Know, which takes a look at things that are typically taught as just fact, like the speed of light, and explores how we know what the speed of light is. It's a really fun show that Eli has put together, and it's great. And then on Saturday, Lindsay will be back and she will do the History of Space Flights, which takes a look at all of the amazing women behind really launching us off the Earth and starting space exploration. There are a lot of women who did so much work that go completely uncredited, and we want to put an end to that. So we have a whole show talking about them. All right. Any more questions?
Nope, that's it.
No? All right. Well, I guess we will stop it there. Thank you, everyone, so much for joining us. Um, we, I was going to say something and completely forgot. Oh, details on schedule and stops for the Dark Sky Caravan are going to go out on Monday. I just finalized the last of our locations, and so we will post that on Monday, so you can find all of that. So we're very excited to have more like of an in-person component to our Dark Sky Caravan again. Thank you, car driving by. That was wonderful timing. Um, but yeah, you can expect that on Monday. We're also open for private shows. You can find information about that. We've got our first few booked, which we're very excited about to have people coming back in. But yeah, all right. So thank you again. Have a wonderful rest of your weekend, and we will see you next time. Bye, everyone.